Hello everyone. In this video, we will see important aspect of geometry of complex number, and that is the argument of complex number. So this topic is very interesting and lots of interpretation regarding the argument of complex number. That depends upon the form of the argument of which complex number we are taking. Okay, so first, what is the argument? First is, what is the argument? See, this is your xy plane and this is your z, that is x plus iota y. Okay, so this is your vector OP. Okay, this OP vector is making angle theta with the positive direction of x-axis. Okay, measured, this angle is measured anti-clockwise. Anti-clockwise we are measuring. So at this time you can have this triangle. This length is x, this length is y. So therefore this tan theta, by trigonometry I can find out y by x, and therefore theta is equal to tan inverse y by x. Correct, theta is equal to tan inverse y by x. This theta is your argument of complex number z. But this is not this is not the only point regarding the argument of complex number. See, this is theta, which is argument of z. This z is lying on first quadrant, but if I rotate this and then again coming back to is the exactly z is lying on that same position, but at that time the argument of this complex number is 2 pi plus theta. Correct. Similarly, I can have 4 pi plus theta. Similarly, I can have 2 pi minus theta, and like that. Correct. So the argument of a z is many valued function. Many valued function. Correct. First point means complex number z can have many arguments, but the argument which is lying between, see, argument which is lying between minus pi to pi, including pi, is a principal value of the argument. This is principal value of argument. So we will always deal with the principal value of argument. Okay, so theta belongs to the open interval minus pi to close interval pi. Means argument of complex number can be pi, or it is lying between minus pi to pi. Again, see, if suppose that the complex number z is lying over here in the first quadrant, then what is your argument is your principal value of that argument. Similarly, if z is lying on second, suppose that alpha is your argument. Okay, and here we will have the pi minus alpha. Here we will have pi minus alpha when z is lying between. Now alpha is definitely this theta. Alpha is this theta. Okay, where alpha is tan inverse of y by x according to the first quadrant. According to the first quadrant. Okay, so whenever z is lying in second quadrant, third quadrant and fourth quadrant, you will take modulus of y and modulus of x, so that you can calculate that particular value of theta or alpha by considering that z is lying in the first quadrant, and according to that, if it is lying in second quadrant, your argument, principal value of z, argument of z is pi minus alpha, and here if z is lying, then alpha minus pi, and here minus alpha. So when complex number z is lying in first quadrant, then the argument is principal value is same. Argument of z is principal argument value of z, that is alpha, which is given by tan inverse of y by x, and it is lying in the fourth quadrant, then the principal value of argument of z is minus of alpha. It is lying in the second quadrant, then the principal value of argument of z is pi minus alpha. Lying in third quadrant, then alpha minus pi, where alpha is tan inverse of y by x. According to that, z is lying in first quadrant. So if it is lying in second quadrant, third quadrant and fourth quadrant, you have to take modulus of that coordinate which is negative. Y is negative or x is negative, take the modulus so that it becomes positive. That means that you are calculating the argument of z by keeping in mind that z is lying in the first quadrant, and according to that you can calculate the argument. So the argument is a many valued function, but the principal value always lying between minus pi to pi. If it is in the first quadrant and second quadrant, whatever you are calculating will be your principal value only. Argument of z is principal value of argument of z is first quadrant and second quadrant, means whatever be the complex number lying over here and over here will always goes to this interval, correct, and belongs to this interval only. So you have to take care only over here when the z is lying in third quadrant. This problem is very important, otherwise rest is nothing. But when argument of z is 0 and pi, it means that z is real. If z is lying over here and here, then their argument will be either 0 or pi. And if argument of z is pi by 2 or minus pi by 2, then z is imaginary. Clear? Because when your z is lying over here, then the argument is pi by 2. When z is lying over here, then argument is minus pi by 2. So pi by 2 and minus pi by 2. Correct? So then your z is imaginary. Okay, fine. In fact, the argument of this 0, one important point is that argument of 0 is not defined. This is not defined. Argument of 0 complex number is not defined. Okay. Up to this we have discussed the very basic concept regarding the argument. Now coming to the geometrical interpretation of argument of z. This is very interesting. See, this is your z. Okay. This is your z and this is your argument, say theta. So here, what is the locus of, if argument of z is theta, then what is locus of z? This is your question. So z is lying over here. That is, it is a ray and it is initiated from origin, and origin is not included because I have told you just now that argument of origin or a 0 complex number is not defined. So therefore here locus of z is a ray initiated from origin. This is important, but origin is not included. Origin is not included. Correct? This is important. And if suppose that we are having like that here, this is z0 and this is z, okay, and this is your theta, anti-clockwise we have measured it, then argument of z minus z0 is theta is a ray initiating from z0 say start, it will start by the z0. Okay, so say if I say that argument of z minus 2 minus 3 iota, correct, is equal to theta, this means it is a ray which is starting from the point 2 comma 3. Got it? This is important. So Coming to this concept now, if I say that argument of z minus z naught 0 is equal to theta. What does it mean? Modulus of argument of z naught, z minus z naught, okay, is theta. That means argument of z minus z naught is lying between minus theta and theta, okay. It is plus theta and minus theta. Argument of z minus z naught is plus theta or minus theta. So what is the locus now? What is the locus of z? See, this is z naught, this is z, this is your theta, this is z, this is your minus theta. So at that time, this is a locus of z is this pair of straight line. These are the pair of straight line. This is okay. So locus of z is a pair of straight line. Okay, initiated from z naught. Got it? And if suppose that this is argument of z minus z naught is less than equal to theta. Less than equal to theta means argument of z minus z naught come mod. So therefore it is less than equal to minus theta plus theta. Got it? So at this time, this is the ray z naught, this is z, this is z. So therefore at this time, this is your theta, this is your minus theta. So this whole region inside and on the straight lines, this whole region is a locus of a z. In that way you have to think about, correct? What question we are dealing over here, this is very interesting question, important question. Let z is a complex number and a is a set of all complex number such that argument of z is pi by 4, okay, and b is a set of complex number such that argument of z minus 3 iota is 2 pi by 3, correct, 2 pi by 3, okay. Okay, fine. Then we have to find out the locus of z, correct. 2 pi by 3. Then find n of a intersection b. How many z are common? So this a set A and set B. See, argument of z is pi by 4. That represent a ray, correct? This is a ray. See, x-axis and y-axis, correct? We are having this z whose argument is pi by 4. So this is not included, you know that. And this is in fact pi by 4 means in coordinate geometry this is y is equal to x line. Y is equal to x line, part of y is equal to x line, correct? So 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5, all these complex number will have the argument pi by 4. Now coming to here, here is argument of z minus 3 plus 3 iota is 2 pi by 3. So this ray is initiated from 3 comma 3, isn't it? So 3 comma 3 is lying over here, na? This is 3 comma 3 will lie in this here. Suppose this is 3 comma 3, correct? So from here we have to draw the ray. So what is the argument? 2 pi by 3. 2 pi by 3 means 120 degree. It will go into the second quadrant. So it is something like that, this one, this ray. But this point is not included. So 3 comma 3 is lying on this ray. Okay. But 3 comma 3 is not lying on this ray. So therefore there is no complex number which is common to both A and B. So therefore n of A intersection B is 0. Got it? Now coming to the new aspect of the argument of complex number, the properties. Properties of argument of Z. The argument of Z1 into Z2 is argument of Z1 plus argument of Z2, and argument of Z1 by Z2 is argument of Z1 minus argument of Z2, and argument of Z की power n is n times argument of Z, and fourth argument of Z का conjugate is minus of argument of Z. So what we are observing here, that properties of argument of Z, it follows the logarithmic law, logarithmic rule. Log of A into B is log of A plus log of B. Log of A by B is log of A minus log of B. Log of A की power something, that power comes over here, okay, log of Z. So similarly, the argument of properties, but the argument of any complex number lying, principal argument lying between minus pi to pi including pi. So therefore here we will have plus minus 2k pi, plus minus 2k pi, okay, plus minus 2k pi over here, 2k pi, plus minus 2k pi. What does it mean? Because if you want the argument is a many valued function. If you want the principal value of the argument of complex number, that principal value always lying between minus pi to pi including pi. So by using this concept plus and minus, you can bring that principal value between minus pi to pi. That's the simple concept. Now on this basis of this properties of argument of Z, we can have so many curves, so many locus of Z. So it is not like that ki only that argument of Z equal to pi by 4 is representing ray. This is one of the kind of the locus, that is a ray initiated from origin, that is for this argument of Z is suppose karo pi by 4, and that means it represent a ray initiated from origin. Okay, origin is not included, whose argument is pi by 4. This is principal value as well, but it is not only one locus, correct? It is not only one locus. Here, by using the properties of the argument of Z, we can have so many locus, and that we can define by using the coordinate geometry also. Just replace Z by x plus iota y and convert it into the coordinate geometry. You will identify whether this locus is circle, parabola, ellipse, or whatever it is, correct? So that where we will use this properties of argument of Z. And now coming to the one again important locus represented by this argument, represented by this. See, suppose there are these complex numbers Z1 and Z2, and this is Z, and this is the angle measured anti-clockwise, correct? Okay, so this ray, okay, turn anti-clockwise by this angle theta to get this ray. This is initial ray, this is initial ray, and this is final ray. At the time, final ray. So here, argument of Z minus Z2 or Z2 minus Z, whatever, Z2 minus Z divided by Z1 minus Z is your theta. This is very important. So look at here, this is final argument of Z2 minus Z divided by initial ray, that is Z1 minus Z, that is equal to theta. And what does this argument, the locus of Z represent? Because Z is lying over here or here or here. See, if I construct a circle, this is a circle, like that. Okay. So you can say that this z if lie here, this is here, the z is lying over here. Again this angle is theta by the concept of circle, that is the angle in the same segment are always same. Okay. So the what is this theta is this theta. So therefore z can lie from here to here, here to here, here to here, here to here. So therefore this represent the locus of z is arc of the circle. Arc of the circle. And if theta is definitely pi by 4 here, and if argument of z2 minus z by z1 minus z is pi by 4, pi by 2, pi by 2, that is 90 degree. Then the arc is semicircle. Then arc is semicircle. And therefore we can say that if theta is acute, then arc is major arc, okay. And if theta is obtuse, then arc is minor arc. Is that clear? Major arc and minor arc. Okay. So this is one of the again an important locus, but you will not get always every time these two famous locus by argument of z. Some other locus are also there where the argument concept is involved. So at that time you have to replace z by x plus iota y and then convert it into the coordinate geometry, so that now you can get the equation in terms of x and y, and you can easily identify that it is a circle, parabola, ellipse, or whatever it is, correct. So that is important thing. Okay, so let's do some problem over here.